Okay, so coming down here to section 9.1, just a reminder of what you guys saw yesterday on your videos on the Chromebooks. We talked about direct, where we said that was y equals k times x, and we talked about inverse, where y equals k over x. And we said that this k value is some constant, so think of it as k constant. You guys were checking yesterday with your values in your tables and trying to see what is your k value. And remember, it had to be the same k value all the way across every pair. Today we're going to continue that a little bit more. You have something called combined variation, which means that you're using both direct and indirect in the same way. So for example, if you look at this one, y equals k with x squared, here's what we say. We read it left to right. You say y varies, and then you say what type. Is it direct or inverse? So varies directly, and then you just say with the square of x, because that's the change. Down here there's a cube of x, so we'll say cube of x. Y varies inversely with the cube of x, because it's on the bottom. Sometimes you have multiple things varying. So for this one here, you'd say z varies jointly with x and y. You could also say z varies directly with both x and y. That's also okay. But notice I didn't have to say anything about k. I just said that it is varying. Here's another one. Z varies jointly with x and y, so that's the same, and then inversely with w down here on the bottom. Here's one where it has two pieces on the bottom for us, w and y. So we just want to make sure we're grouping those two pieces when we talk about it. So z varies directly with x, and then inversely with the product of w and y. That's a way of grouping them together. We could have also said inversely with both w and y. Again, just different ways of grouping them. So looking at some examples down here, these are formulas that you've seen before, you're familiar with them. These are areas of circles, heights, volumes of cubes, all this sort of stuff. So if we were to describe this one here, we're always going to start with what's on the left. So we'll say A varies, and then what you talk about after that are the variables. That's why we say varies. So pi is your constant. He's the 3.14. He doesn't change. He's going to be the same as all your k's are up here. Notice we didn't mention k's. We just said what type of variation was happening. So A varies directly with the square of r, or r squared. A varies directly with r squared. For our next one, again, find the thing that's the constant, the thing that doesn't change. 2 is not going to change for us. That'll always be the same, but the variables will be a and b. So we'll say h varies directly with a and inversely with b. And then for this last one down here, we don't see a constant or a k written. So if there's nothing written in there, that's the same as really saying that there's a 1 as your constant, right? It's just not written, but it's just a 1. So we don't have to say anything about it again because it's the constant. We'll just say v varies directly with, we could say L and W and H, or we could just say with the product of L, W, and H. All right, once you have that, go ahead and flip your notes. We're going to combine this skill of writing with the idea of plugging in numbers. So we're going to, first of all, write the function that models each relationship. And then we're actually going to plug in numbers for those relationships right here, okay? So start with your first thing. Z varies directly with X and inversely with Y. So directly, remember that means X is going to be just straight on top, Y inversely. And the sentence doesn't say it, but there's a K, because there's always some constant. That's the whole idea for all these formulas, is we don't know what the constant is, but it's there. We're often trying to find it. So this is important for us. Even though it's not written here, you will put in some K. And the K, we always talk about it as being up top. Okay, so we never put a K in the bottom of a fraction, and that's just because we find it easier to read it as being an up top number. So this is the formula in pink. Then they give us some values. They give us X is 6, Y is 2, Z is 15. We're going to plug in those three values. So Z is 15. X is 6, Y is 2, and remember there's still a K times 6 up top. By plugging all those pieces in, the only unknown is K. So if we know these three, we could figure out what K is and rewrite this model with the K in there. So we need to move the 2 and move the 6. 2 is dividing, so we'll go ahead and we'll multiply both sides by 2. And 6 is multiplying, so we can go ahead and divide both sides by 6, and that will cancel the 6's. So we have 2 times 15, which is 30, over 6 equals K, or K equals 5. We're going to go ahead and plug that in. So we get Z equals 5X over Y. And that's the first part of what they're asking. They told us what type of pattern, they told us what the variables could be, so we found K, and now the very last part, they would like to know what is the value of Z with this formula when we have X is 6 and Y is 11. So this is like a part 2, if you will. We'll say Z, 5 times 6 for X, 11 for Y. So we get Z equals 30 elevenths. And this one doesn't simplify, so we'll just leave it as 30 elevenths. All right, let's try another one together. Let's go ahead and let's skip down to C here really quick. I'll have you guys do B with your partners in a second. So for C, C varies jointly with D and the square of G. That's our first part. Then it gives us the values we need to plug in, and then it's going to ask us to find a value. So start with our pattern. C varies jointly with D and the square of G. The jointly part just means that D and G go together. It means they're both up top. There was nothing in here that said inverse, so everything's on the top of the fraction. D and G squared, and don't forget we have the K in there as well. We'll plug in the values they give us, so we'll plug in 30 for C. D, 15, and then G, make sure you put a 2 with a squared for that one. So using our PEMDAS here, we'll have 2 squared, that's 4. So 4 times 15 is 60, and 30. We need to divide both sides by 60. So we'll get 1/2 equals K comes up here. So when we rewrite this, we have C equals 1/2 times D times G squared. And then for the part 2, find D when C is 6 and G is 8. So we plug in a 6, 1/2, don't know D, and G is 8 squared. So we are looking for this guy right here. So again, just use PEMDAS to undo. There's a times 1/2 in here. You can always undo a times 1/2 by multiplying by a 2/1, the reciprocal fraction. So 2/1 times 1/2 cancels to be 1. 2 times 6 is 12. So 12 equals D 8 squared. 8 squared we know is the same as 64. So D times 64. Divide both sides by 64. And 12 over 64, we get a decimal, or if we use our math frac button, 3/16. So 3/16 is D. Okay. All right, I'd like you guys then to go ahead and try B with your partner. So go ahead and try to figure out what's the first part, what is the pattern. Plug in your numbers so that you can put in the K value, and then use the last part to find the value they ask you for. Okay, let's go ahead. All right, ladies and gentlemen. Go ahead and check, see how you did. Here's your formula for part B, and here's the value of Z. Give me a thumbs up if this is what we got. Awesome. Okay. All right, so questions on this one, I'm going to come around and check those with you guys. Let me show you your homework really quick so you have that. Homework for this section, 9.1b, is page 481. numbers 19 through 27 odd, 39 through 45 odd, and then 68 and 69.